Hello all, today in this video I'm going to show ANN classification for diabetic dataset and from scratch. For ANN we have in the same channel we have made a video for ANN but with different datasets. Since now in this video we are working with the diabetes dataset. So simultaneously after ANN we will be working with CNN and also we will be working with stacked CNN. That is after this we will just make a comparison between all these models to just make which model is providing better results. So in this video, we are only going to see about ANN. So first we can run the libraries. The libraries which we are going to use in this work include the Keras. In that we are going to import the layers and then Matplotlib, Pandas, then Seaborn, NumPy, iteration tools, TensorFlow, sklearn. In that sklearn, we are going to use metrics, then pre-processing, and also some model selection. And then we are going to import warnings. If any warnings is found, it will be just rejected. Then we are importing our data set, which is the diabetes data set. This diabetes data set which we are using is having nearly three and four entries like date, time, patient ID, code and value. So then this is the info of the data set. You can see over here. Here date time is the object type and others are integers. Then we are going to see the details regarding the data set. Here also the data set details only. Then we are going to group the value of the data set. Then we are going to create an SNS plot for the DF value. Next, in the next thing, also we are also going to create an SNS plot. Then an SNS pair plot we are going to display for this data set, which is diabetes data set. Then we are going to display a heat map. So this is the heat map of the data set, and then we are going to drop the date time since because object values cannot be used in this data set. Next, other than the value, because value is considered as the target, so other than the value we are just dropping all the values from the x for the x variable, and for the y variable we are only using the y the value which is the target. Now we are using the train test split function. Here we are using 80 to 20 split. That is because our test size is 0.2. If you want some 70-30 split means you have to change the test size as 0.3. Then we are pre-processing our data by using a standard scaler. Then we are displaying the shape of the X train and also a Y train. Why? Because this shape we have to call over here. In this input dimension we have to call over here. So it will be easy for us if you are displaying the shape. So now this is the ANN code from scratch. Here we are in ANN we are using the layers like two dense layers. In the first dense layer we are having nearly 11 units, and in the second layer only one unit, and the optimizer which we are using is Adam. Activation is sigmoid in the second dense layer and the ReLU in the first dense layer. Then we are going to train our model by using the fit function. Here we are using 50 approaches. If you want to work with some different approaches means you can just change the number of approaches. Mm, so it will take some time since you may know for model training it may take some time, and the time where increases based on the approaches only. So if you don't want much things, because if you think that this there will be don't much not much variation between this values for every approaches, means you can just end by 10 approaches or 20 approaches and all. Why? Because increase in approaches only will increase the time. So once that will be completed, we are going to generate those values in an graph. In this graph, you can see we are going to plot this training accuracy and validation accuracy, and also training loss and validation loss in a graph. Why? Because for a better model, this validation accuracy should be better when compared to the training accuracy, and also the validation loss should be less when compared to the training loss. So now nearly 40 approaches has been completed. So after the display of the graph, we are going to predict the performance metrics parameters like precision, recall, and F1 score. For that, I am just using the function called classification report. By this classification report, we can acquire the values of the precision, recall, and the F1 score. I think now the 50 approaches has been completed, and now you can see the graph is displayed here. You can see when compared to training accuracy, the validation accuracy is only high. This proves that this ANN is also a better system, and when compared to training loss, the validation loss is only less. So see, this for this ANN is a better system only. So also you can just see this we can just run this to just display our values. So this is the thing which we have got for every classes. Now we can just display the confusion matrix. I think for but other than for the first two classes, other classes was having only less entries. In the previous, if you see, means you can see only 0 and 1 is having high entries, to some high, but when compared to 0 and 1, everything is low only. So only you can see in the confusion matrix, there is only less values for the other entries. So this is the ANN code. In the next video, we can just work with CNN code. Thank you.